All right, now, last one is we're going to draw, not last one, but last video. We're going to draw a triangle with vertices negative 6, 0, 4, negative 2, and 5, 3. So let's go ahead and draw this. So negative 6, 0, so that's A. B is at 4, negative 2, and C is at 5, 3. Okay, so go ahead and plot this bad boy right here, connect all the dots, and we got this beautiful triangle. All right, now we're going to show that this triangle is a right triangle. So I'm under suspicion. Now, we're not sure, but if it was a right triangle, I'm suspicious that angle B would be the right angle. All right, so how do I do this? There's several right ways. We're going to do the easy way first. All right. What kind of lines make a right angle? Well, the answer is perpendicular lines. All right, how do lines, what are so great about perpendicular lines? Slopes are opposite reciprocals. So when we learned about perpendicular lines in a coordinate plane, this was one of the reasons. All right, we did that in Unit 3. Well, we're going to start graphing shapes in coordinate planes, and we need to know if lines are perpendicular. And they do a lot of things with coordinate geometry, just typical engineering stuff, architectural stuff, even computer graphics for your favorite movies, such as Wreck-It Dory and Finding Ralph. All right. So, anyways, well, let's do this. All right, we need the slope of AB, and we're just going to go ahead and count. All right, remember it's rise over run, so I'm down 2 over how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I count it right. So down 2 over 10. So the slope of AB was down 2 over 10, which becomes negative 1/5. Okay. Now let's do the slope of BC. Remember, it's rise over run, so I'm up 5 over 1. All right. So the slope of CB is up 5 over 1, also known as just 5. So opposite, well, does this meet the qualifications of opposite reciprocals? Well, remember, opposite means change signs. So one's positive, one's negative. Check. We have negative 1/5 and 5. Reciprocals, what does reciprocal mean? That means flip. Well, we have negative 1/5 and 5 over 1. We did flip them. Check. So we can say this. Let's be very mathematical. We can say triangle ABC is a right triangle because angle B is a right angle. You guys might hear my dogs in the background. My golden doodle just got up. My black lab is now laying right at my feet. All right, and then last one is draw a triangles whose vertices are 0, 0, 3, 3, and negative 3, 3. All right, let's do it in this color right here. Let's mix up the colors a little bit. So 0, 0, 3, 3, and negative 3, 3. All right, so we got this triangle right here. Ooh, this is a beautiful triangle. A little foreshadowing. All right, we're going to classify the triangle by sides, then determine if it is a right triangle. All right, so we're not even going to talk about slopes right now. We're going to do a different technique. All right, so I'm just going to focus on sides first. All right, so focusing on sides, let's do AC. All right, let me do it like this. Okay, so we did the distance formula before, but now we're going to switch up the methods and remember the Pythagorean theorem shortcut, and that's kind of going to be the punchline of this whole problem. we can make this into a right triangle. And I can say, well, we have 3, 3, and I would just call this x. All right. So to find AC, I'm going to say x squared equals, oops, let me do it like this. Remember we have Pythagorean, let me do this, Pythagorean theorem. Pythagorean theorem, that's a squared plus b squared equals c squared. So that's what we're using right now, the Pythagorean theorem. Shortcut, it's the same thing as the distance formula, just on steroids. So we're going to have 3 squared plus 3 squared equals x squared. 9 plus 9 equals x squared. 18 equals x squared. All right, take the square root of both sides, and let's just keep it like we'll just say x equals the square root of 18, or in this case AC equals the square root of 18. All right, we could plug that into our calculator. We get 4 point something. It's going to be about 4.1-ish. I forget exactly. I don't have a calculator right next to me. All right. Now, similarly, set up Pythagorean theorem shortcut over here, so just make a right triangle. And this probably won't blow your mind too much, but we have 3, 3. For fun, I'll call this y instead of x. So to find AB, we're going to have 3 squared plus 3 squared equals y squared. So this is the same exact setup as before. So you can see a bunch of math's going to happen. Y is going to equal the square root of 18. Well, that means AB equals the square root of 18, and it's going to be about 4.1-ish. I forget exactly. I should have had a calculator ready. Anywho, and then the third side, CB or BC, we can just go ahead and count. BC equals 6. All right. Now, also, when focusing on triangle ABC, triangle ABC is a right triangle only if Pythagorean theorem works. So this side right here, CB, that's the hypotenuse. So that's 6. And then we have our smaller sides are the square root of 18, which is 4.1-ish. But, so I'm going to say, well, a squared plus b squared equals c squared. Well, the legs that form the right angle would be square root of 18 squared plus the square root of 18 squared, and c is 6 squared. So if this is true, then it's a Pythagorean, or then it's a right triangle. So if Pythagorean theorem works, it's a right triangle. Square root of 18 squared, it's going to blow your mind, just 18. Square root of 18 squared, it's going to blow your mind, it's just 18. And 6 squared is 36. So we get 18 plus 18 equals 36. So 36 equals 36. Pythagorean theorem holds true. So this triangle had 2 congruent sides and a right angle. So it's a right isosceles. It's right because Pythagorean theorem works for the side lengths. An isosceles, 2 congruent sides. Okay, that's it. I hope you enjoyed it. Have a good